we have the rocket all put together. First test we're using C65 engines, which has about double the power of a B65 engine. The first letter being the burn time, and second number is the thrust. The last number is the delay time from the burn to the recovery fire.
What's the recovery fire?
Sorry, not fire. Charge. I don't know what I'm thinking.
So what is the recovery charge?
What that does is it's a little charge at the top of of the engine that blows out the parachute in the top,
Okay.
thus activating the recovery system.
All right. Getting set up.
Okay. So what I've done here is I've got some talcum powder, or otherwise known as baby powder, and I've unfolded the parachute in the rocket, which I should probably put another quick dusting on it, and dusted the parachute with it. That way it doesn't stick and it saves your rocket. And then what you do is you fold this parachute in half. Make sure this isn't twisted up like I've somehow managed to do. And you fold it into pizza shapes, like so. You fold it in half this way, and in half again, and wrap it up in the string. Now, wrap it up so that it's loose enough that you can line it up underneath this nose cone. Now, I'm going to need to go grab the lettuce, which we are using for our substitutes for wadding, which generally you want to buy some actual. Now, I've got the lettuce. I'm going to kind of get some of this loose floppy stuff. Get as little of this crispy stuff as I can. And I'm going to do maybe two, since this rocket is longer than the other one, I'm going to do 2 wads of it. So I have enough room for the parachute, etc. While having a sufficient amount of wadding. Now you want to break this up to tiny pieces so it doesn't get jammed. Now I'm going to put this, oh crap, I unfolded the parachute. I'm going to put this string down here. I'm going to mainly try and keep the Kevlar string down there in the bottom, and I've somehow managed to mash these all up into one.
Keep going.
Okay. Alright, second wad. Now, you may have noticed over here I've got the engine. I've got that already before. What you do is you first have to put the igniter in there and then plug it up with the engine plug. That helps it build pressure so it gets started off easily instead of a lot like you want a bullet to fit just perfectly in the barrel of a gun. That's too much lettuce. Oh dear, how am I going to get that out? It's too much lettuce. Now that I have that problem solved to the best of my abilities, I'm going to re-roll this parachute and start putting this little stretchy string down there. Gosh, hands are really cold. Somehow there's snow up on the mountains after that big snowstorm, but not down here in Highland. This happens to be our favorite frisbee golfing park. Not rolling this time. Okay, now I've got the nose cone back on. It's fine if there's like a little parachute thread sticking out, that's no problem. Now, you're gonna put your engine in here. These rockets can be bought at places like Smith's, the Scout store, the craft stores, hobby stores, almost everywhere. They're really easy to find. Well, at any rate, we're gonna come over here to our launch pad. Generally, people will put something with like a little flag on the top of this, just to make sure that no one trips over this. Make sure you take that off, unless like I did on the last launch. one of the clumsiest things I've ever done. Okay, now I've got this 9-volt battery. I'm gonna connect the wires to it, and up it goes. Engine we used for this one was B64.
2, 3, 4, 5,
Recovery charge
6,
already.
7, 8, 9, 10. Look at the letters. 11, 12, 13, 14, 15,
Lucky birdies.
16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26.
So it's gone about approximately 150 yards from where we were before to here at the parking lot. I'd say it went up about 500 feet or just 100. It's kind of hard to tell.
It is hard to tell. But we did count off how many seconds it took to descend. So if we can determine, looking at the film later, approximate terminal velocity with that parachute, we can estimate the height with not very good accuracy, but it'll be good for comparison purposes, for comparing the differences in heights between rockets.
Yep. So, interesting fact about these motors is they smell very good.
What does it
And-
smell like?
Well, sulfur, like all fireworks do. It's not actually fireworks, but it uses mostly the same chemicals. And despite smelling like sulfur, it's mainly potassium nitrate and sugar.
Sugar?
Yeah, sugar is the combustant. And while potassium nitrate does burn and create lots of gas, and it burns very hot, which is what causes this to go up, it doesn't catch fire very easily, which is why you need the sugar and rust powder in there.
Interesting.
Sorry, I didn't include the rust powder in there the first time I mentioned it.
In the category of things that don't burn easily, I think we can conclude that lettuce makes an excellent wadding material.
I'm not gonna lie, it's pretty great. Still got a bit of talcum powder in here, but I'm still gonna give it another dusting. Considering how far it went and the fact that it landed on asphalt, I want to be careful with this. That worked way better than the other times. Also, fun trick with talcum powder. Say you're at the beach, and there's sand stuck to your feet. You know it's time to go. You can put this in a shirt and put a rubber band on it, and it'll just let through just enough after you, before you get off your towel, when your feet are dry and don't have any sand on them, rub some talcum powder on it and your sandals, and they won't get any sand stuck to them.
Really?
You won't get that sandpaper effect.
I've never heard that.
That was a beach life hack from a channel called The King of Random. You guys should go check it out. It's just cool science stuff, all that stuff. Sometimes it's just straight up funny things. Or,
You could hit that plane. Look how low he is.
wow. That are exactly that, random.
Oops, I gotta watch what I'm doing.
Sorry, cameraman got a little distracted by the low-flying plane over there.
Back to our previously scheduled program.
We've got tons of lettuce left over, so I'm thinking we're gonna go home and make some sandwiches and eat those while we're editing this into a full video.
Yeah. You know, we were looking for just a quick, desperate replacement for the Estes recovery wadding that we needed. Estes recovery wadding is not cheap. You know, for some little bits of fire retardant paper, this whole thing, which is served wadding purposes for each of our launches, and it will also serve a much better purpose for our lunches. It was 99 cents.
Really? I didn't know lettuce was that cheap.
So I think this might be our go-to wadding material in the future.
It worked pretty well.
Yes.
In fact,
It's very sustainable. It's biodegradable, and it's
and
of course
you get to feed some
very green.
Save the planet. Now, oftentimes the igniters and plugs will come with the rocket. So all you have to do is pull out one of your igniters from underneath this little tape, and pull off one of these little plugs. Now you don't want this little protrusion right here. Man, this is hard to do with cold hands. I can't put the gloves on because they flop around on the tips of my fingers.
Yeah.
Okay. You know, actually that one won't matter, so. Here we go. Stick this in there. Now, if you get more powerful engines, it'll always obviously go much higher than this. These do. And once you have that in there like so, you put this just right underneath here. Now, see, as that fits over like that, that'll keep it from falling out. When the recovery charge fires off, that got bent. Now, we're gonna come back over to here now. Put this on our launch pad. Hopefully it doesn't fall down on one of those people.
This is true.
Now you gotta make sure that neither of these touch that part or this metal part, otherwise it'll short circuit and you won't get a launch. So make sure that the circuit is only completed inside the rocket engine. Now we're gonna start the circuit again. 3, 2, 1.
4. Whoa, there it is. 1,
And there's the recovery
2,
charge.
3, 4, 5, 6, 7, 8,
And if you look
9,
closely, you can see the
10,
lead is floating around.
11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26,
We'll be
27,
putting this on a YouTube
28,
channel called
29, 30.
About 90% of the rocket's mass is generally taken up by the fuel. And which is interesting when taking into account the weight of the rocket, which is easily only about 2 ounces. I've never weighed it with the rocket, but it's still remarkable that it's able to get that kind of height. Now, the way you determine the change in mass of a rocket is with the equation delta V equals VE over in MO over M1. Delta V being the acceleration rate of the rocket, VE is the exhaust velocity, and MO is the original weight of the rocket, and M1 is the final mass of the rocket. That means as it reconsiders fuel, as it goes up into the atmosphere, it's getting lighter. So, a while ago I read about something interesting called the gravity roll, and that's how they get extra height with such as a Saturn V rocket, which is what they took to the moon on the Apollo 11 mission, and is one of the better rockets we have. So, what that is the engines give the rocket a slight pitch, and the torque to turn it comes from gravity itself, essentially harnessing gravity, which is no longer science fiction. So, as that gives it better height and conserves fuel for when it's up in space. Now, an interesting thing about space is you don't need to use too much fuel because there's no air resistance up there. So you give it a quick thrust enough to get it moving, and it just keeps moving. And that's why it's good to conserve fuel, even though you don't have to use very much. Because when you need to get into orbit, that costs a lot of fuel. Getting back costs a lot of fuel. And landing costs a lot of fuel. All things you need to take into account. And say, Apollo 11 mission, they had to bring back samples, so that was some pretty heavy math. Okay. So another little snippet of knowledge here is that there is such thing as atmospheric gravity changes. As you get higher up, gravity gets weaker and weaker and weaker until there's none at all up outside of the atmosphere. Of course, there is gravity from the Earth outside of the atmosphere, but you have to go a little ways longer, and then there's none. So, as you go up, you're getting further and further away from the center of gravity, which means the pressure from the gravity is getting weaker and weaker and weaker. And that's how atmospheric gravity changes work. So, it's been easily about 5 years since we've last uploaded. Sorry about that for those of you who have subscribed to our channel, and we'll try to do it more often. Still don't have a definite topic that we want to stay with, but we'll try and keep you updated on that. Make sure to go and see the other videos we've uploaded, such as When Chinchillas Attack. What was the name of the other one?
I don't remember.
Well, it might be in the suggestions. See you later.